Hey guys, just wanted to jump on here real quick. A lot of people have been asking about my intro to probability routine, so shut up, Mr. Holland, cringe. Okay. Anyway, well, we're starting a little bit of probability. Yeah, so please pause the video at any time, of course. If I ever go too fast, you need to copy anything down. So just a quick review, some fractions, everyone's favorite. Fractions, essentially, it's always amount over total, right? So a lot of times it's introduced using circles, pizzas. That's how I introduce it, right? The amount filled in is 1. The total slices is 4, right? So that represents this um, fraction. And so we could also attribute it to different things, right? Here we got 5 people, 2 of them have green hair, 2 have blue hair, one has red hair. So we can see what the fraction of people that have green hair, right? So we have the amount of green hair, 2 over the total people, 5. There we go, right? So this is going to be the fraction that represents this. And so fractions can also be thought of in terms of probability, right? Kind of like if we have this pizza right here, what's the chance that if you select one at random, it'll be the filled in one, 1 over 4. Okay, and so we're going to start probability using a deck of cards. And so a deck of cards contains, there are 52 cards in the deck of cards, and the values are, we have an ace card, we have a 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have a jack, queen, and king. And so the jack, queen, and king, those are known as face cards because they have the face on them. And also, if you're not aware, most people know this, but some people aren't fully aware of cards. Half the cards are black and half the cards are red. Okay, and there are also 4 suits. So the 4 suits are spades and clubs, those are black, and then we have hearts and diamonds, those are red. And so we have 52 total. And so just using this as our sample set or our total, we can calculate the basic probability of drawing a certain card. So let's say you have a deck of 52 cards, you draw a card at random. What is the probability that you draw a 6? And so we remember the amount over the total, and the amount of 6s in the entire deck, there are 4 of them. So that's going to be 4, and then the total number of cards, 52. So that's our fraction, or our probability of drawing a 6, and then we can simplify it, divide the top and bottom by 4, and we get 1 over 13, which kind of makes sense because there are 13 different kinds of cards, and 6 is one of them. And so what's the probability of drawing a black card? Well, let's count how many black cards there are, 26, and there are 52 total. So we can simplify that also, divide the top and bottom by 26, and we get 1 over 2. And so, what would be the probability of drawing not a 6? Once again, what's the amount of not 6s there are? If there are 52 total, and there are 4 6s, then 52 minus 4, there are 48 cards that are not 6s, over 52. Once again, divide the top and bottom by 4, and we get 12 over 13. Either one of those work for now. Probability ace or 3, how many aces are there? There are 4. How many 3s? 4. 4 plus 4 is 8. So when it's or, we kind of like add them together, over 52, which once again we can simplify to 2 over 13. So this is the basic kind of probability that is going to be like the first half of the assignment, just amount over total. And so now we're going to start to introduce something called independent events, and this is just fancy terms. When I'm back tomorrow, I'll make this more clear, so don't worry if you don't fully understand all this fancy words and stuff. But independent events, they basically describe scenarios where the outcome of one event does not affect the outcome of the other. And this makes more sense when we talk about what dependent events are, but essentially it's like if you roll a dice and you flip a coin, right? They don't affect each other, right? They're separate things. And so another example would be if you have a deck of cards, right? Let's say you draw a card, and then you put that card back, and then you draw another one, right? So like since you put the card back, it doesn't affect the next one. It's still like 52 total, right? And so, like I said, an example of something that's not an independent event would be if you are drawing 2 cards from a deck of cards, and after you draw the first one, if you do not put it back, because when you do not put it back, there are now 51 cards in the deck when you draw the next one. But like I said, we'll go over more of this tomorrow. We're essentially focusing on independent events, that 2 completely separate events, okay? And it is pretty straightforward. It's going to be using fraction multiplication. And so what's the probability of drawing a king, putting it back, and then drawing a queen? Well, the probability of drawing a king, there are 4 kings in the deck out of 52, and put the card back, and we are going to multiply the probability of drawing a queen, which is also 4 out of 52. So it's just the probability of a king multiplied by the probability of a queen. And so we just multiply straight across. And so I'm actually going to simplify these first before I multiply straight across. So it'll make it a little easier. So 4 out of 52 simplifies to 1 over 13. 4 out of 52 also simplifies to 1 over 13. Multiply those across. 1 times 1 is 1. 13 times 13 is 169. So the chance of this happening, of drawing a king, putting it back, and then drawing a queen, is 1 out of 169 chances. And so now let's say we have a coin and a dice, right? So a coin, there's heads and there's tails. 2 options. Dice, 1, 2, 3, 4, 5, 6. So what's the probability of drawing tails? 1 out of 2. And we're going to multiply that by the probability of drawing 4. There is 1 4 out of 6. So that's going to be 1 over 2 multiplied by 1 over 6, which is 1 over 12. Not that big of a chance. Lastly, you flip a coin that has heads on one side, tails on the others. I don't know what coins don't have that. And what's the probability of drawing 4 tails in a row? So that's essentially saying you want a probability of drawing tails, then tails, then tails, then tails. And you multiply them all. So that's 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2. Multiply across. That gives us 1 over 16. And like I said, it's just an introduction, and I know I'm not there today, so if you don't fully finish that everything, don't worry. We're going to be going over this more again tomorrow, so just do your best for today. Thank you all. Appreciate you all. Have a good day. Bye.